Today we have to find optimality check or optimal table of this particular decision matrix, or you can say this is a transportation problem. How we can check the optimality? In this particular problem, it is asked that we have to find the transportation cost using northwest corner method. First we have to apply northwest corner method to find the transportation cost, and then we have to find the optimal table or optimal cost of the check optimality of the table. So in order to do that, we have to first find the transportation cost using northwest corner method. In northwest corner method, you have to select the, you already know, I have already made a video about northwest corner method. In northwest corner method, you have to select the northwest corner. Look, if I draw the direction, this gives W, this east, this north, this direction gives you northwest. So in case here is the northwest among this particular matrix. Okay. Now I have written about the optimality check in transportation problems. We are going to find optimality. We have to determine the optimal table for this particular problem. So let us find the transportation cost first using northwest corner method. So we have to allocate in the northwest corner the demand values accordingly. For doing that, we have to allocate over the northwest corner side. Look, here is 20, here is 40. So we have to allocate 20 over here, the least one, and it becomes 0, and this becomes 20. Now, as it is 0, you can strike this whole row off. Next, excuse me. So next remains this one, this one. So this one is the northwest corner method, northwest corner. So you have to select minimum these two values, this 60, this 20. So you have to select 20 over here. Okay. So it becomes 0. Now there remains 40 only. So this is 40, this is 40. This means you have to select 40 over here. So you have to calculate now the total cost. The total cost here begins for total cost for NWCR is equal to how much? 20 into 2 plus 20 into 1 plus 2 into 40. You can find that 40, 60, 140. Okay. By solving this table using northwest corner method. Next, we have to check whether the solution obtained from NWCR is optimal or not. So we have to again draw this particular table. Let us have this table with the allocations also. So we have got here 2, here it is also 2, here it is 1, and here it is 2, and this is 20, this is 60, this is 40, this is 40, and the allocations were in 20 and 20 and 40. Okay. So we have to find whether this allocated matrix is optimal one or not. Okay. In order to do that, we have to apply the UV method, or sometimes known as modified distribution method. And right over here, the method is known as modified distribution method, or MODI method, or you can say UV method. And what are the steps? The steps are, you have to find the first step is you have to find the Cij values of all allocated cells. Cij values of all allocated cells. First step. In order to do that, you have to calculate U1. Say I give the name as, it is also UV method, so you have to rename the cells. Okay. So let us write this as, say this one is U1, this one is U2, this one is V1, and this one is V2. Okay. Now you have to write the values of Cij. In order to do that, you have to calculate U1 plus V1. U1 plus V1 is 2. U1 plus V2, or you can say U2 plus V1. U2 plus V1. U2 plus V1 is equal to, U2 plus V1 is equal to 1, and U2 plus V2 equal to, U2 plus V2 equal to 2. Okay. Now I have not taken this particular cell. Why? Because this method says we have to check the optimality of the particular matrix. In order to do that, we have to find the Cij values of the allocated cells only. Okay, not this one, as because this is not allocated. This one's only allocated. So we have to calculate the Cij values of this particular cell. These are the values. Now you can see we have got 3 equations. Okay? We have got 3 equations, but we have here U1, V1, U2, V2, 4 variables. So in order to find the values of the 4 variables, we have to put a variable as 0, or we have to take a variable as 0, as because we are not having 4 equations, but we are having 4 number of unknown variables. So let's put U1 equal to 0. Okay. Putting U1 equal to 0, we can have from this above equation V1 equal to 2, U2 you can find as V1 equal to 2, V1 equal to 2, U2 equal to minus 1, and sorry, this one is V2, okay, and V2 equal to, U2 you have found, this one, U2 plus V2, this one is U2 plus V2, okay, U2 plus V2 is 2, so V2 is equal to, U2 you have got minus 1, it goes over here, it gives you 3. Okay. Now you have all the 4 values, V1 equal to 0, V1 equal to 2, U2 equal to minus 1, and V2 equal to 3. Now let us tell you that what does this Cij values, these are the Cij values, okay. So this Cij values gives you, V2 we have got 3 over here, I can write it over here, it is equal to 3, you can write over here, V1 equal to 2, you can write over here, U1 equal to 0, U2 equal to minus 1. So Cij value indicates that if you have to transport from S1, these are the S1, S2, this one the E1, and this one is the D2. Okay. So in order to transport from S1 to say D1, you have to take 2 units of cost, or if you have to transfer it from S2 to D1, you have to pay 1 unit of cost. So this is the significance of CIJ values. This is the significance of the CIJ values. Okay. Now the next step is to find ZIJ value. What is this ZIJ? What is ZIJ? Look over here. ZIJ is nothing but ZIJ. You already know what is CIJ. Now you have to calculate ZIJ. ZIJ is the summation of UI plus VJ. Okay, this is ZIJ. We have to find, next we have to find the value of CIJ minus ZIJ values. Okay. Next, first we have to calculate ZIJ, which is a summation of UI CJ. Next we have to calculate the values of CIJ minus ZIJ for all unallocated cells. Keep in mind, for all unallocated cells we have to find CIJ minus ZIJ. Next, let us find the values for, why we are calculating CIJ and ZIJ value? As because CIJ minus ZIJ value gives you the optimal solution. How? Say this CIJ value comes as positive, or it can come as negative, or it may remain 0, which means 0 means the Z value increases, negative means the Z value decreases, and 0 means Z value remains constant. So our aim over here is to minimize the transportation cost, or you can say we have to maximize the value of Z. Okay. In LPT, we have already seen that we have to maximize the value of Z, which is the profit. Similarly, you can say if we can increase the value of Z, the transportation cost will decrease. Okay. Now we have to calculate ZIJ value. Okay. For unallocated cell, for allocated cell, the ZIJ value and the CIJ value remain same. For allocated values, for allocated cells, the ZIJ and CIJ is equal to ZIJ. For allocated cell, the value remains same. So CIJ minus ZIJ for allocated cell remains 0. So we have to work out with the non-allocated, unallocated cells. Means there is only one cell which is not allocated, and this value is this one. For this one, look, this is the CIJ value. And what is ZIJ? I have told you UI plus VJ. UI plus VJ. UI plus VJ is the ZIJ value. And what is that? Here UI is -1, VJ is +3, which gives you ZIJ value of sorry, I am mistaken. For this cell, ZIJ value is UI plus VJ. UI is 0 and VJ is 3. So ZIJ value is, I can say, 3. I can write it over here as 3. 3 is the, say, 3 is the ZIJ value. Is the ZIJ value. You just remember one thing. You have to calculate only ZIJ value of non-allocated cell. That is this one in this case. not for other allocated cells. Why? As because in allocated cell, Cij value and Zij values are remaining same. But in unallocated cells, you have to calculate the Zij value. Zij value, you can also cross check over here. Look, for Zij value over here, Ui, U1 plus V1, that is Ui plus Vj, which is 2. For this cell, -1 and 2 gives you 1. For this cell, 3 and -1 gives you 2. So you need not to calculate Zij value for the allocated cells. You have to calculate only Zij value for this particular unallocated cell, which is 3 over here. Now the difference between Zij and Cij and Zij gives you Cij minus Zij gives you -1. So you can see that over here I have written over here Cij minus Zij, when comes negative, the Z value becomes goes decreasing, which is not preferred. We have to find an optimal table in which we have to make this value going upwards. This one. Okay. In order to do that, so we can already decide that this table is not optimal. So we will have to make a new optimal table. To construct that, we have to make a new table. Okay. So let us construct new optimal table. So in order to construct that new optimal table, let us draw the old one first. Okay. 2, 1 is a 20 allocated over here. Okay, this is also allocated one, 20, this is 40 allocated one, and in this cell we have found the Cij value as 2 equal to Cij and Zij equal to 3, and the difference is -1. Okay, no problem. Now if we have to calculate or construct the new optimal table, we have to make a loop. How to make a loop? Let us draw the table first. Look, the center, this is the 20, 2, this is 2, this is 1, this is 20, this is 40, and this is the unallocated cell where 2 is the Cij value and Zij equal to 3, and this is -1. Okay. To construct the optimal table, we have to make a loop. How to make a loop? We have to find the most negative cell and start making loop in horizontal and vertical manner, and we have to make sure the loop must touch every allocated cell. In this case, most negative cell is this one, as because this has the -1 value as Cij and Jij value. Okay. So this one is the most negative one. So we will start making loop from this side on. In order to construct the loop, you have to draw horizontal or vertical line, and you have to keep in mind that you have to touch every allocated cell. These are the allocated cells all. So in order to construct this particular loop, you have to touch every allocated cell. Okay, you have to touch every allocated cell. So we are going in this way, and we are making a particular loop. Then we have to put negative and positive values accordingly. First start with the negative value, then positive, then negative, then again positive. Okay. Now Then we have to find the cells with the negative allocation. This is the negative allocation and this is the negative allocation. So there are two cells with having negative allocation, and we have to select the least one from the two cells. So the least one among these two cells, we have value 20. Okay. So this one is minus 20, this is minus 1. So the least one is minus 20. So we have to select this one, minus 20. And the next step is, in the above matrix, 20 and 40 are the negatively allocated cell values, and least one is 20, which needed to be added. After making the loop and keeping in mind the loop must touch the allocated cells, you have to put positive and negative values accordingly. In order to do that, first you allocate positive value to the first cell, okay, from where you have started making the loop. Okay. Next you give negative value, next you give positive value, next you give negative value. Now you can see these two cells has the negative value, this one and this one. In these two cells you have to find the most negative, you have to select the least value. Least value is the 20 out of 20 and 40. So you have to select 20, and you have to subtract 20 from the negative cells, negative valued cells, and you have to add 20 to the positive valued cells. So after doing that, we have a new table. A new table gives us these values. This is the new table. You have selected 20 and you have subtracted 20 from the negative valued cells, which gives 0, as because 20 minus 20 is 0, and 40. 40 minus 20 gives you 20, and you have to add this value to this positive value cells, which gives 40 over here, and this is only 20, as because no allocations were here. So 20 plus 0 is 20. Okay. So our new table becomes somewhat like this. Now you again have to calculate the U1, V1 values, and you have to check whether it comes negative or positive or constant, and accordingly we will declare that it is optimal or not optimal. Let us write the cell numbers. This is say D1, this is say D2, this is say S1, this is say S2. Okay. So for this one we have already U1 equal to 0, and we have here, as you know, U1 equal to 0. Then again you can easily calculate, this cell has value 2 already given over here. Okay, 2, and this one is given over here as 1 already. Okay, and this one is 2 also, and this one is 2 also from the previous tables. Okay, this is 2, 2. Okay, now this one is U1 equal to 0, and V1 we have calculated as 1, and V2 we have calculated, we can calculate from here as 2, and U1 equal to, we can say U1 is 0, sorry, this one is U2, U2 is 0, and this, okay, this becomes U2 is 0, so V2 is 2, Okay, no problem. And next comes the we have to find the un reflect the unallocated cell, and therefrom we can find the Cij and Jij value and the difference between the two. Here this one is the Cij value. This one is we know as Cij. Okay, no problem. Now Zij value. How we can calculate Zij? Zij for calculating Zij, you have to calculate. We know already Zij is the summation of Ui plus Vj. Okay. Now for this particular cell, Ui is given as 0 and Vj is given as 1. Okay. So Zij gives you value of 1. This is the Zij. Okay. So Zij is 1 over here, which is positive. Okay. So from this table we can say that this table is the most optimal one. This is the optimal table. This table is optimal table. We need not have to construct another table to make it optimal. So this is the optimal table. From this optimal table we have to calculate the costs of transportation, S1 to D1, then S1 to D2, S2 to D1, S2 to D2. In order to calculate that, let us write the values over here. S1 to D2 is 20 units, S2 to D1 is 40 units, and S2 to D2 is 20. Why we are not taking this one? As because these are the allocated cell, not this one. So we only are taking the allocated cells only. Okay. So these are the total cost incurred for transporting. Okay. So in order to calculate the total cost, minimum cost, we have to multiply the same rule we are going to perform, that is the multiplication of allocations with the cell values and adding them up. So 2 into 20 plus 1 into 40. Okay. Next plus 2 into 20, which gives you rupees 140. Now you can see that, so this one is 120. Mistake. It is 120. But earlier we have solved the same problem using northwest corner method, and we have obtained the value of rupees 140. So you can see that from the optimal table we are getting 120, which is 20 rupees lesser than the northwest corner method. So this is all about the UV method or modification.